What up, what up? Chapter 4 review, or topic 4 review, whatever you want to use it. If you're using enVision Algebra 1 Common Core for Pearson, you've come to the right place. This chapter goes over solving systems of equations, so let's just get right into it. First thing that we're going to talk about is solving system of equations by graphing. Okay, so I'm going to graph that guy in black. I'm just going to do it the old-fashioned way. I'm going to start at 3, so go up to 3, put a dot there. My slope is -5/3, so up 5, can't do it. So I can go down 1, 2, 3, 4, 5, go right 1, 2, 3, put a dot there. And that's pretty much the only way I'm going to have a line. I'm awful at drawing lines with this pen, although started out weak, ended up strong. Let's graph this one in blue. So let's start at -3, which is down here. My slope is +1/3, so up 1, right 3. Up 1, right 3, can't do it again. Down 1, left 3. Down 1, left 3, can't do it again, but that's all right. The solution to any system of equations is where the lines intersect. And these two lines intersect at that spot right there. That spot right there is right 3, down 2. So 3, -2, there you have it. Now, what I'm going to do is I'm going to use Desmos to show how I can solve any system. So I'm going to use Desmos once, and this method that I'm about to show you is going to work for any system of equations, no matter what they look like and no matter what the directions are. So if it says substitution, if it says elimination, it's going to work. I'm just going to use the same exact problem. Desmos, I'm going to split the screen, and yeah, that'll be it. Okay, solving a system of equations. Let's just type them in as is. Y equals -5/3. Don't forget to move to the right. X plus 3 gives me one of my lines. Bada bing. Now I'm going to go down, and I'm going to type out y equals 1/3, like that. Move to the right, x minus 3. And let's see where these two lines intersect. So they intersect, it tells me like right there, 3, -2, which is what I said. So I'm not a liar when I tell you that the answer is 3, -2, and this just proves it. And remember, you can use these to solve any system of equations problem, whether it's graphing, substitution, elimination, whatever. Thank you, Desmos. Now let's solve this by graphing again. I'm going to graph this. What color do I have? Green. So I'm going to start at 2, +2. My slope is -2 or -2/1. So I'm going to go up 1, 2/1. Up 1, 2. I can't do it. Down 1, 2/1. Down 1, 2/1. Down 1, 2/1. That's it. So I'm going to do my best to draw that line. I'll take it. Let's graph you in blue. Start at -2, and slope is also -2. Interesting. Up 1, 2/1 dot. Up 1, 2/1 dot. Up 1, 2/1 dot. Ran out of room. Down 2, right 1 dot. Draw a line. My solution to a system of equations is where the lines intersect. Well, gosh darn it, I have parallel lines. So where do my lines intersect? What's that? They don't? Correct. So what's my solution? There is no solution. And that, ladies and jelly spoons, is my answer. No solution. So that's graphing. Let's move on to substitution. Now, the process of substitution is what you want to do is solve any of the equations, top or bottom, for any variable. Well, in this case, the top and the bottom are both solved for y. So what you do is you take one of them, this is called the blob method, and you plug it into the other equation, right? So I rewrite the bottom equation replacing y with 4x plus 3 because y is 4x plus 3. So 4x plus 3 equals negative x minus 2. And now you just solve it, okay? Let's add x to both sides. Add x to both sides, cross u out. That gives you 5x plus 3 equals negative 2. Subtract 3 from both sides, and 5x equals negative 5. Divide both sides by 5, divide both sides by 5. X equals negative 1. I have my x value. Now I also need to find my y value. So I could use any one of these equations. Since I can barely see the top one, let's use the bottom one. You plug that into any equation to solve for y. So y equals negative. X is negative 1, so I have a double negative 1. That's supposed to be a parentheses, minus 2. Y equals double negative 1 is just regular old 1, minus 2. And 1 minus 2 is negative 1 again. So x is negative 1, y is negative 1. The point where these two lines intersect is negative 1, negative 1. And just like I said in the first problem, if I wanted to, I could use Desmos pretty easily to get the answer to that. I would just graph both of these, find out where they intersect, and they will intersect at negative 1, negative 1. All right, let's do it again. Step number 1 in substitution is make sure one of your equations is solved for a variable. The top one, can't do much about it, but the bottom one is already solved for y, so that's good news. And once it's already solved for y, you circle it, blob. So y is negative 5x minus 17. Take that and plug that into the y upstairs. So I'm going to rewrite the equation upstairs, negative 3x minus 3, but instead of y, I'm going to write out parentheses negative 5x minus 17, and then just kind of keep continuing to write the top. All right. First thing I do is distributive property, so I have negative 3x. Negative 3 times negative 5 is positive 15x. Negative 3 times negative 17 is 51. Positive 51, that equals 3. Combine like terms. I can, and I will. And that gives me 12x plus 51 equals 3. If I subtract 51, I have 3 minus 51, which is negative 48. So 12x equals negative 48. Divide by 12. Divide by 12. And up here, I'm going to write out that x equals negative 4. Now that's one of my variables. I need to find the bottom, or I need to find y, so I'm going to plug it into the bottom one because it's easiest to find y when you have the bottom available. Solve for y already. Y equals negative 5 times negative 4 minus 17. Negative 5 times negative 4 is 20. Minus 17 is 3. Yeah. So if x is negative 4 and y is 3, the point where these two lines intersect is negative 4, 3. I don't know what I did, but I did it. I did it. Elimination, or as SpongeBob would say, elimination. Remember that episode? 80s kids, 90s kids. Okay, when you're doing elimination, first thing you need to do is make sure everything's lined up and everything is lined up. It doesn't look so pretty, but I'll make it look pretty in a second. I have negative 7x, I have minus 2y equal sign number. I have x minus 2y again equal sign number. What I'm going to do is I'm going to multiply this bottom one by a negative to make it a positive 2y. See, if I have a negative 2y and a positive 2y, then I can add these lines and it'll disappear. So step number 1 is you want to make sure that things are lined up. Step number 2 is try to find a coefficient that is the same number but opposite. Well, I have the same number, but I'm going to make it opposite by multiplying the bottom equation by negative. So I'm rewriting the top, negative 7x minus 2y equals negative 13. By multiplying everything on the bottom by a negative, I now have negative x positive 2y, because negative times negative 2y is positive, equals negative 11. You now add the lines. So let's choose a different color. It's been a few minutes. Negative 7x minus x is negative 8x. Negative 2y plus 2y cancels out. Equals is equals. And negative 13 minus 11 is negative 24. Divide negative 8. And x equals regular 3. So now what I want to do is I want to take this guy and plug it into any one of the equations to solve for y. It doesn't really matter. I'll plug it into the top one because it doesn't have as much schmutz. So negative 7 times x, well, I just found out that x is 3. So negative 7 times 3 minus 2y equals negative 13. Multiply those two together, I get negative 21 minus 2y equals negative 13. All these negatives, add 21 to both sides, and then that brings down negative 2y equals 8. Divide by negative 2, divide by negative 2, y equals negative 4. X is 3, y is negative 4. The point where these two lines intersect is 3, negative bore. I've been making a lot of videos, so bore, pretty accurate. Is boring? Are these guys lined up? Mm-hmm. Is that the same coefficient but opposite? No. Is that the same coefficient but opposite? No. So let me pick one. Let me pick x. If I multiply the bottom guy by negative 3, that'll turn that negative 3x or regular negative x to 3x. So that'll become 3x, negative 3x. I can add, make things go away. Life is good. So I'm going to rewrite the top equation, negative 3x plus 3y equals 4. The bottom one is going to be positive 3x. Negative 3 times regular y is negative 3y equals negative 3 times regular 3 is negative 9. Now I add these equations. Negative 3x, positive 3y goes away. I'm sorry, negative 3x, positive 3x goes away. Positive 3y, negative 3y goes away. So what do I have on the left? Nothing. That's going to equal 4 plus negative 9 is negative 5. 0 equals negative 5. My variables disappeared and I'm left with something that doesn't make sense. It's a no solution. That's right. When using elimination or substitution, if your variables disappear and you're left with two numbers that don't equal each other, it's a no solution. If my variables disappear and I get a number equaling itself, like 5 equals 5, then that's the infinite solutions. But that didn't happen here. Did it? It did not. It doesn't. The price of 6 slices of pizza and 4 drinks is $37. The price of 4 slices of pizza and 6 drinks is $33. How much does 1 drink cost? Let's let pizza be X. Let's let drinks be Y. So 6 slices of pizza, 6X, and plus 4 drinks, 4Y, equals 37. The price of 4 slices of pizza, 4X, And 6 drinks, 6y is 33. I'm going to do elimination here. But I'm going to have to be a little clever here for this guy. I'm going to multiply the top equation by, I'm going to make the x's go away. So I'm going to multiply that by a -4, and I'm going to multiply the bottom one by regular 6. And what that'll do is that'll make you -24. That'll make you regular 24. The x's will disappear. So let's rewrite the top equation. -4 times 6x is -24x. -4 times +4y is -16y. -4 times 37 is -148. I hope, I think. Yes. 6 times 4x is regular 24, so the x's will go away. 6 times 6 is 36. Y positive equals 6 times 33 is 198. Let's add these guys up. You will go away. You will become 20y, and you will become 50. Ugh. Just making sure I didn't do anything dumb when I did any of these. I didn't. No, that's right. So divide both sides by 20, divide both sides by 20, and y equals 2.5. Oh, perfect. That's what it wants me to do. It wants me to find out how much one drink costs. Well, if I have y equals 2.5 and drinks are y, then y or drinks is $2.50. All right, I can handle that one. I didn't like it, but I can handle it. Let's graph an inequality in 2 variables. Now, the way you graph an inequality in 2 variables is you graph it the way it normally is. So y is less than or equal to 3x minus 5. So you start at the -5 down here. You go up 1, 2, 3. You go left 1, 2, 3, 4, 5. Put a dot. Now, those are the only 2 dots that I can make. Now, this is a less than or equal to. If it was a less than or a greater than, I would make a dashed line. However, if it's an or equal to, I make a solid line because the line counts. So there's my line. This is a less than or equal to, which means if I shade underneath the line. Underneath the line is down here, so I'm going to do a little shading right here. Pick the skinny pen. That's all right. Works out just fine, baby. All right, another inequality to graph. This one's a little bit worse, more of a standard form type of thing, but I'm not afraid of anything. In fact, something magical is going to happen here, but we'll get there in a moment. Y is not all by itself. I have 5x over here floating around, so let's get rid of it. Minus 5x cross you out. Drop down the -3y, drop down the less than or equal to. These 2 guys don't combine because one has an x and the other one doesn't. So I have -5x minus 15. Is y all by itself now? No. So I'm going to divide both sides by negative. I'm dividing everything by negative. So thing number 1 you have to remember is when you divide both sides by a number, you divide everything by that number. Thing number 2 that you have to remember is when you divide an inequality by a negative, you flip the sign. So I have -5 over -3, which becomes +5 over +3x Negative 15 over negative 3 becomes 5. Now I can graph. So I'll put a dot at 5 right there. Can't go up and over, so I can go down 1, 2, 3, 4, 5 over 1, 2, 3. Down 1, 2, 3, 4, 5 over 1, 2. I'll force it in there. I'll force it right there. There you go. All right, connect the dots. This is a greater than or equal to, so it's not a dashed line. It's a solid line because you include the line. Good job drawing a line by me. Now I have to graph above the line. When you have steep lines like this, you have to imagine above the line being like, if this were a mountain, which side of it would you climb? And you would climb up here, okay, above. So I'm going to get my highlighter. I'm going to choose pink because for breast cancer awareness, I need it to be a little bit bigger than that. Yeah, that's more of a purple. It's still pink. Blackpink, the band. K-pop band. And there you have it. And remember what all of this means, same thing with the last problem, is if I were to ask you to choose any possible solutions of this system, you could choose anything over here. Negative 3, positive 3 is a solution. Negative 5, 0 is a solution. Even points on the line like 0, 5 is a solution because anything that's shaded or since the line is not dashed, anything that's on the solid line counts too because the line counts. And so can I. 1, 2, 3. All right, so we have a system of inequalities, which means we're going to graph twice, we're going to shade twice, and what we want is where both of my shadings meet. So I will graph you in black. All right, I can graph it right away. So I could start out at 2. My slope is 1 over 2, so I go up 1, right 2, up 1, right 2, or I can go down 1, left 2, down 1, left 2. This gets a solid line because it's greater than or equal. Actually, in this case, it's less than or equal to, so I'm going to draw a solid line. Not bad if I do say so myself, except for the very end there. We'll just make it look like I didn't mess up. Yeah, perfect. I'm going to shade this in, let's do like a yellowish. So I'm going to shade you in yellow. Doesn't show up that well. That's all right. I'm shading underneath the line because it's less than. So, yeah, this is going to take a minute or two. I'm shading underneath the line because it's a less than. So while I'm shading, just a gentle reminder that when I graph the other one, I'm going to shade that one too. And wherever both of my shadings meet is going to be the region that is the solution to the system of inequalities. Try saying that fast a bunch of times. All right. I like it. Let's graph the next line and let's choose red. I can graph this one right away, put a dot at negative 3 right there. My slope is negative 2 over invisible 1, x, so I'm going to go up 2, left 1, up 2, left 1, up 2, left 1. I can also go down to right 1. That is a less than, no, or equal to, so this is a dashed line. Looks absolutely miserable, but that's what it is. I'm going to shade this in a bluish color so that when I have my shadings or the areas where the shadings meet, it'll turn nice green. This is less than, which means under this red line. So just like in the last problem, if you're imagining this being the mountainside that you can climb on, underneath it would be the other side. So let me shade, let me shade, let me shade, shade, shade. So far, nothing special happens. However, when I cross the line, these two, I was hoping that this would become like a nice greenish color, but that really didn't happen at all. Anyway, the yellow and the blue meet right here. I'm going to label that R. I'm going to label that R to demonstrate that this is the feasible region that I want. So the area right here where both of my lines meet, where both of my shadings meet, is the solution. So points like -4 is a solution, -5, -5. I can include this line, so I can pick -4, 0. I can't include the dashed line, so I'm not allowed to pick 0, -2. But I could pick 0, -3, and 0, -4, and 0, -5. So any point in this R is a possible solution. And I could do this on Desmos, and in fact, maybe I will. All right, now I'm going to solve a system of inequalities. So let's start typing things in. I've got y is less than. To get your less than, you click the little keyboard. And this is actually less than or equal to. So pardon my talking. Less than or equal to, I don't need the keyboard anymore. 1/2, so 1/2, x. So you can see the shading starting to take place, plus 2. All right, that's one of my guys. Let's click down here. My other guy is y is less than, so I could just type out the regular is less than button instead of having to click the keyboard. -2x -3. So green, purple, double shading right there. It's hard to see. If you ever want to change your colors, you can click on the wheel and click on whatever you want. I mean, you should probably use like primary colors, like stuff like that. And that way you can definitely tell what's what. But yeah, this purple shading is my the region that I care about. So there you have it. That's graphing inequalities. All right, welcome back. I'm going to graph you on a coordinate plane. And I'm going to start out by graphing it in blue. So this is x is less than or equal to -3. So something in the form x is equal to or x is less than or equal to is going to be a vertical line. Since this is less than or equal to -3, it's just going to be a vertical line going through -3. Now, it's less than or equal to. So when I shade, I'm going to shade everything to the left of it. So let me choose these colors. Let me choose blue. I'll do blue on blue. So I'm shading everything to the left of it. How's everybody doing? Good? Yeah, me too. Doing great. All right. I'm going to graph you in red. This next one, I'm going to graph it in red. Start at 2. Go up 5/3. Up 1, 2, 3. Can't. Go down 5, left 3. Go down 1, 2, 3, 4, 5. Left 1, 2, 3. Ooh, a dot goes right there on that blue line. I can't go down 5/3 again. So these are the only 2 dots that I can use, and it's going to be a dashed line. So something that looks like that. Yeah. This is less than. So I'm shading underneath the red line. Underneath the red line. Okay. So there. And the part where the 2 shadings meet is that tiny little triangle right there on the bottom left that I started out with. This is tedious. Tedious shading. Slim shading. This would be the slim shading. That would be the fat shading. Anyway, that area right there, that little tiny triangle right there is my feasible region. So not a lot of space, but that's how you do it. That's how you do it. All right, the fun stuff, word problems. Which combination of cans could Nate buy? All right, so I have myself a picture. I have shading here. So I guess fishing bait, number of small cans, number of large cans. All right, so anything in this shaded area would be a possible combination. So 2 large. 6 small, that won't do it. Not you. 2 large, 10 small, that will do it. Are there more than one answer? 6 large, 10 small, no, that won't do it. 8 large, I'm not even going to try. So it's B. That wasn't bad. That wasn't so bad. Which system of inequalities describes the graph? All right. I'm going to use Desmos for this one. All right, so this is going to be a train wreck and a half. Let's just type things in and see what happens. The first option, option A, is 4x plus 3y is greater than 24. All right. And you know what? No. Because first off, I have solid lines. So it can't be A to begin with, and it can't be C. So I regret typing that out. So let's skip A and C because my picture has solid lines and solid lines only. Rewind if you need to see what I'm talking about. All right, so B, if I do 4x plus 3y, make that greater than or equal to 24. That's one of them. If I do 5x plus 8y, make that less than or equal to 40. That is what I want. Let's get rid of it. That's what I want. Yeah. Yeah, I got my intersection right there. Yeah. And here's my double shading. Oh, I like it. 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 So it's B. Hooray. It's B. B, 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 B. All right. So whatever Desmos said, I believe it. I believe Desmos with every inch of my being. All the books in a bookstore window display today will be mysteries, and biographies. Neat. The system of inequalities below describes the relationship between the number of mysteries, X, and the number of biographies, Y, that could be in the display. So X plus Y has to be less than 30, which this is telling you that the total amount of books has to be less than 30. And twice the mysteries has to be less than 3 times the biographies. Okay. So let's graph it. Let me quick subtract X from both sides over here. So I have Y is less than negative X plus 30. Okay. Let me flip everything over here to make it 3y is greater than or equal to 2x and divide everything by 3 so that I now have y is greater than or equal to 2/3 x. I'm going to make my own coordinate plane. And since this is a real-life problem, I only care about the first quadrant. I'm going to go up 10, 20, 30. We'll do the same thing here, 10, 20, 30. Y is less than or equal to negative x plus 30 is going to look like this line right here. Let me try that one more time. Let me get rid of you. Let me try that one more time. I'm basically connecting 30 to 30. Not to be confused with 34, 30. Nah, forget it. I want everything less than or equal to, so I'm going to shade underneath that. Great. Now, the other guy, what I'm going to do is I'm going to graph that in green. Start out here, up to right 3. And I'm going to shade above. And so my feasible region lives like here. So what's a possible solution? How about 10 and 15? How about that? 10 and 15. What does that mean in this real world problem? 10 mysteries and 15 biographies. I could have used whatchamacallit for that. Desmos. I didn't. Probably should have. Too late. Ain't doing it now. You can't make me. So believe it or not, that one I didn't consider a crazy hard one, but I probably should have. So let's see what the crazy hard ones look like. It can't be much crazier than what we just dealt with. At a theater, the price of 4 adult tickets and 3 child tickets is $156. The price of 3 adult tickets and 4 child tickets is $145. I think this problem's a whole lot easier than the last one. What is the ticket price for 1 adult and 1 child? So let's let A be adult be X, child will be Y. So 4 adults, so 4x plus 3 child, so plus 3y is going to equal 156. The price of 3 adults, so 3x, and 4 children's tickets, 4y is 145. All right, as much as I really don't want to do it, I think the best way to go is elimination. So I'm going to get rid of my x by multiplying the top equation by -3 and the bottom equation by 4. The top equation becomes negative 12x minus 9y equals negative 468. I think so. Negative 3 times 156. Negative 468. So I got on the bottom equation regular 12x plus 16y equals 4 times 145. 680. No, 580. Oop, I'm talking too much. 4 times 145. It's 580. All right, add these two equations. Cross u out. Negative 9 plus 16 is 7. 580 minus 468. 112 divided by 7. 16. So y is $16. So y is 16. Ugh. Y is $16. Now I have to find x. So I could use any of these equations right here to find x. So I'll use the bottom one, 3x plus 4y. Well, y is now 16 equals 145. 3x plus 64 equals 145. Minus 64, cross u out. 3x equals 111. Wait, no. 14 minus, no. That's 81, dummy. 81. Divide by 3, you get 27. That's a lot, makes a lot more sense. Still very expensive, ridiculous. What do they want me to do? They want me to, what is the ticket price for one adult and for one child? So my adult is $27. I'm going to add that to a child's wages, which is 16. Add those up, you get 43, baby. Name the inequalities that make up this system. All right, I like these. I'm good at these. This one right here is going to be y. Since I'm shading below and I'm including the line, it's going to be less than or equal to. My slope is going to be, here's a dot, up 1 over 1, 2. So up 1 over 2, x. And I go through 2, so that's my one equation. My other equation is going to be y is, here's my dashed line, and I'm shading below it, so less than, and it's dashed, so not equal to. My slope is a negative slope. Here's a dot, up 1, 2 over 1. So negative 2 over 1 is just negative 2x, and it goes through negative 3. I like that. I like it. Like it. A lot. In the graph of an inequality, the region to the right of a dashed vertical line goes through the point -4. Wait. In the graph of an inequality, the region to the right of a dashed vertical line through the point -4, 0, okay, is shaded. So -1, 2, 3, 4, dashed, and the region to the right of it is shaded. So if it's a vertical line, it's x and then a number. Since I'm shading the right of it and the right of it only, it's going to be x is greater than, no equal to, and it's going to go through -4, which makes sense because that x is also -4. That's the inequality. I like that one too. And I like problem 20 because we're done. C is the solution to the system of equations. That's inequalities. C is the solution to the system of inequalities. Bad job by me creating this problem. So that's the solution. What does each other region represent? Okay. D is a solution to this equation. B is a solution to this equation. And A is a solution to neither. That is topic 4. I don't know how long this video is. They last forever, but hey, more money for me, and I really don't make any. I mean, the time that I put in these videos, I get like $9 a month. Maybe in a year from now, I'll blow up. I don't think anyone's going to be like, hey, let's look at that almost 40-year-old bald guy and watch his stuff. You never know. Thanks for watching, everybody. Love you all. Stay blessed. Goodbye.